Okay, now it's recording. An emitted electron has a linear momentum of 5 exponent negative 24. Calculate the de Broglie wavelength of the electron. Okay, very simple question. So for question 1, okay, you have the momentum P, and now it was want to find the wavelength. So you just use the de Broglie wavelength formula. H over momentum. So H is Planck's constant 6.63 exponent negative 34 over the momentum 5 exponent negative 24. Okay, everything is in SI unit, so no problem. Okay, so let's calculate, and then you will get the answer 1.33 exponent negative 10 meter. Okay, that's the answer. You try and calculate and see, is it correct? Yeah, I'm sure it's correct lah. Okay, so for question 2, okay, put in a second. So for question 2, now a non-relativistic electron beam in an electron microscope formed by a similar setup to an electron gun used in the Davidson-Gilmour experiment. What is the voltage needed? Okay, so I wanted to ask the voltage to accelerate an electron which has a de Broglie wavelength of 0.25 nanometer. So just use this formula, lambda equal to H over 2 MeV. Understand this formula? Okay, let's continue. 2 MeV. Okay, actually this formula is derived from EV equal to half mv square, and then lambda equal to H over mv. Okay, so if you want to use this formula, these two formula to do also can. You use the wavelength to find the velocity first, and then once you get the velocity, you can find the voltage. But all you want to use this formula. But bear in mind, okay, this formula is not provided. Yeah, if you check the formula given in the exam, okay, check the formula given in the exam. Go to this chapter. You see, wave properties of particle. You only give one formula, lambda equal to H over momentum. So you don't have the formula of you don't have this. You don't have. You only have this de Broglie wavelength formula. You don't have this lambda equal to H over 2 square root 2 MeV. You don't have this formula. EV equal to half mv square also don't have. The formula only give you this one. So you have to, if you want to use this formula, you must memorize. You must memorize, class. Okay, you have to memorize this formula. Yeah, it's not provided in the exam. Okay, so alright, you just put in the value and you can solve it ready. Okay, it's 0.25 exponent negative 9 meter. Okay, and then what's the H? 6.63 exponent negative 34. Okay, over this mass, use a mass of electron. Yeah, because you are using electron, so mass of electron is 9.11 exponent negative 31. Okay, actually you can find from here. Okay, where is the, hold on a second, let me check. Mass of electron, tutorial 8. Oh, it's already here. Here there is a mass of electron, 9.11 exponent negative 31. Okay, that's the mass of electron. Okay, I'm correct. And then electron charge is 1.6 exponent negative 19. Okay, then voltage. Voltage is I want to find the voltage, isn't it? So I need to find the voltage. So at last, voltage I get what answer? My voltage I will get, yeah, 24.1 volt. Okay, you calculate and see, you will get 24.1 volt. That's the voltage. Next, question 3. Question 3. So what is the de Broglie wavelength? So I want to find lambda. Okay, accelerate through a voltage of this is the V lah. Okay, potential difference of 700 volt. So lambda, just use the formula h over square root 2 MeV. So again, you have to memorize this formula. It's not given, it's not given. So same thing lah. Mass is using mass of electron and then electron charge. The voltage you just put, 700 volt. Okay. Planck's constant is 6.63 negative 34. Then you can find wavelength. You can find your wavelength is equal to, after you calculate, you get wavelength 4.64 exponent negative 11. Okay, so that's the answer, 4.64 negative 11. Okay, that's all for these 3 questions. Very simple and direct questions. Bye.